One of the important aspects of the sun that we need to learn is that not only is the sun just an amazing source of power and energy, it also kind of attacks us with something called solar wind. And the solar wind streams out from the sun in all directions and reaches every part of our solar system. It is primarily made up of hydrogen ions, positive and negative, and helium ions. But the interesting thing is that it also contains every element of the periodic table. So not only does the solar wind contain hydrogen and helium from the sun, but the sun is also sending us magnesium and carbon and I don't know, barium and potassium and on and on and on. So because of that, and the fact that we know our sun is actually a low mass star and it's limited to fusing hydrogen to helium and helium to carbon, the fact that all of these other elements of the periodic table is coming from our sun, that is evidence that our sun is actually a second generation star made up from the remnants of other stars. And that's why our sun, even though it's a low mass star, still contains all the other elements of the periodic table. All right. So we get this solar wind, primarily hydrogen and helium. The next thing we'll talk about is something called solar weather, or just solar activity, solar events. And the first thing we need to discuss is something called sunspots. And sunspots occur because the sun has this magnetic field, but because the sun rotates at really odd speeds, because it's just a sphere of gas, and so it doesn't rotate uniformly. So the middle, will rotate at an extremely much faster rate than at the top or the bottom of the sphere, and that will cause the magnetic field to get all twisted up, and the sun has all these loops of magnetic fields. And so that's going to cause some problems for the surface. When there's a strong area of magnetic field, it's going to block the heat from reaching the surface. And so parts of that surface of the sun is going to be cooler, and that creates a sunspot. And oftentimes they come in pairs or even clusters. And I'll draw some sunspots here. All right, so sunspots associated with magnetic fields. All right, and from these sunspots, what will often happen are these flares, or these expressions of fire and energy called prominences. Prominences. I believe that's spelled correctly. And these prominences will extend out, hundreds of miles. And sometimes when these prominences interact with one another, what you end up with is a different reaction where you get a pretty big explosion, I guess you can call it, called a solar, I'll keep it in red, solar flare. Okay, and that solar flare is going to be a huge explosion, and of course that's going to, shoot out even more solar wind out into space. And then one more, and I'll give it a green color even though it's the sun. Also associated, they believe that it's associated with solar flares, but they haven't really made a definite connection, is something called a coronal mass ejection, which is just an unbelievably huge explosion. And coronal mass ejections are just simply abbreviated CMEs. And CMEs actually shoot out, plasma from the sun itself, and it'll shoot plasma out into the space. But the point of it is that all these occurrences on the sun help to really send out bursts of solar wind all over. And so in my next video, I'll explain some of the ramifications of the solar wind reaching us. But for now, we'll stop. And with the fact that we have this thing called solar weather, starts out with sunspots caused by magnetic field. Sunspots are cooler than the rest of the surface of the sun. It can lead to prominences, which can also lead to solar flares. And it is believed that solar flares might also be connected to something called coronal mass ejections. And these are, the huge explosions that throw even, parts of the sun are thrown out into space. All right, we'll see you in part 2.